we are going to discuss stepper motor, that is the last section of actuators. In actuator section we discussed hydraulic actuators, pneumatic actuators and electric actuators. In electric actuators we already discussed DC servo motor, and today we are going to discuss stepper motor. Actually, the main difference between a stepper motor and a servo motor is it's in rotation. In stepper motor we get a stepping rotation, and in servo motor it is continuous rotation. Now to control the continuous rotation we have to use gear system, etc., or to slow down the current rating to control the rotation of a DC servo motor. In case of a stepper motor, we get a stepping rotation. If we want a 15-degree rotation, it actually gets 15 degree with the help of some type of stepping inputs. There is discrete current inputs, pulse inputs. Okay, also the stepper motor is also called stepping motor. That is because it gives a stepping rotation, that's why we call it as stepping motors, and have been used mostly in computer peripherals and in robotics in order to get a slow movements. A stepper motor provides output in form of discrete angular motion increments. Discrete angular motion increments. Step by step rotation gives that discrete steppings. It is actuated by a series of discrete electrical pulses. For every electrical impulses, there is a single step rotation of motor shaft. Actually, usually we used in light duty applications, being its load carrying capacity is very much low. Usually 2.2 kg in desktop type stepper motors. So that's why we go for light duty applications, or we use stepper motors in light duty applications. Okay, you can see the figure of a stepper motor here. In this figure you can find a stator, that is the 4 electromagnetic poles. You can find pole 1, pole 2, pole 3 and pole 4, and you can find a rotor at the center that have 2 poles, which is a permanent magnet. Usually it's a permanent magnet, and the stator assembly is a coil assembly. So these are the main parts of a stepper motor, right? Coming to the working of a stepper motor, if the electromagnetic stator poles are actuated in such a way that, so for example, pole 3 is north and pole 1 is south. Let us assume pole 3, we give an electromagnetic stator pulse, or it gives some electricity in such a way that we make the pole 3 north pole. You can find the pole 3 in the figure, and pole 1 in south. Pole 1 is south. Okay, so the if the stator rotor position is as shown in the figure. Okay, we all know that opposite poles are attract each other. If the permanent magnet pole is north and winding pole is south, it will get attracted. As in the figure you can see that north pole is attracted towards P1 and south pole is attracted towards pole 3. Okay, and if the stator is excited so that P4 is north pole and pole 2 is south, the rotor makes a 90-degree turn in clockwise direction. You can see a marking there. It rotates 90 degree, that north-south direction bar magnet line, okay, that will rotate 90 degree in clockwise direction if P4 is north and P2 is south. Okay. So by repeatedly switching the current to the stator electronically, it is possible to make the motor motion of the rotor. So we can obtain stepping rotations by giving or by alternating this electric signal. If firstly we give or we select pole 3 and pole 1 to make it north and south, then we change it to P4 and P2, that is pole 4 and pole 2. Then the permanent magnet will, or the rotor will rotate 90 degree, and again we make pole 3 south and pole 1 north, then again a 90 degree clockwise direction or rotation occurs. Okay, this is what happens in stepper motor. By properly giving electrical pulses to these poles, we can make different steps. Also, there is a facility to make it a half position by activating both the poles simultaneously, creating an opposing field to the rotor by creating an opposing pole to both windings. In both windings, it creates an opposing field to the permanent magnet and it gets deflected at the center. So you get a 45 degree angle. So that's called half stepping. Also, we can increase the stepping, or we can decrease the degree by increasing the number of poles or by increasing the permanent rotor region, permanent magnet region. Okay. So coming to the resolution, the number of steps per revolution that is of the stepper is determined by the number of poles in the stator and rotor. If we increase the number of poles, we can increase the resolution of the device too. So there is a relation between stepper resolution and step angle, that is n equal to a divided by 360 degree, where n is the resolution and a is the stepping angle. So n is equal to a by 360 degree. So even we can divide the 360 degree rotation into different angles. Commonly available stepper motor gets 1.8 degree stepping. Yeah, 1.8 degree stepping. So usually in desktop robots we use 1.8 degree stepper motors, and also we can achieve half stepping, that is 0.9 degree half stepping angle also. So that's all with the stepper motor. Okay, thank you.